Hello friends, back we are with another episode of the Test-Driven Development Screencast. Here we talk about good software development practices like TDD, evolutionary design, highly disciplined programming and so on. So far, where we ended up in the previous episode is we are able to report when we have a bad query, when we have no matches, and when we have exactly one match for a given query. And the plan for this episode and to continue working on is to be able to return multiple values that are matching a given query. So let's switch back to the code. And here we have a to-do list where we have written down that we are gonna start working on the finding multiple items. So let's make sure first that we are green. And I also have to mention that you would notice that I'm having here a new setup here for the audio, for the video, and also the entire development environment is new. I'm not very used to the new keyboard. Let's see how that goes. But hopefully everything's gonna be just fine. So we also spoke in terms of refactoring that we want to move away some of these tests here, because the test case here says find one match, but essentially here we have tests that are not related to finding one match but rather to finding no matches. So I'm gonna write that here as well. Split current, or maybe split find one match test further on. So yeah, we'll see how that goes, but first of all, let's start off by another test case, because I need a new test case for this new behavior that I'm gonna be building now. So we're gonna be working on multiple items. Let's create new file for that. So it's gonna be find multiple matches test. I'll make this a bit smaller. Oops, it's way too small. Something like that, because I'm forced to use the presentation mode, but sometimes it's hard to see when there is in presentation mode. The code is too big. So I have to find balance. So let's start off by test. What happens when I have multiple matches found? So I'm thinking about introducing new search state, which will have matches instead of match, and it's gonna care a list of values that are matching the given queries, something like matches. And then that's gonna be my searcher, search state live data value. It's way too long, this line, but as I said, I have to use the presentation mode, so I couldn't make it the code smaller. So let's leave with this a little bit, and then let's write enough code to make this compile first. Now my searcher is gonna be a searcher, and now it takes a query validator and repository. I've noticed in the previous episode that I left it as an exercise for you to write test doubles for the query validator. Would have been nice if I had that sort of stub that I can use here, say passing validator, instead of, which is, I mean, in this case it's fine, because now the query validator here, it takes only one argument here, which is configuration. That's fine, but if this query validator had, like, it was a bit more complex to instantiate, and the query validator does not pay much, big role in terms of checking the behavior of multiple matches found, I think would have been nicer to maybe use such stub, but I think it's fine for this for now. If you happen doing that in your case, maybe you can use that one here. Then let's define what's the repository. And the repository takes list of available values, and now the idea here is that we are gonna have more than one value in the repository that would match the query, and then we want all of the matches back. So it's gonna be a list of, and then say item 1 well, here I would add something else. Come on. 1 value, well, maybe 1 value, and then other, something like that. And then I would perform search for 1, and then let's introduce first these matches. Oops. Which is gonna be a list of, and here I'm gonna have item 1, then I'm gonna have 1, and then I'm gonna have 1 value. So they all include 1, which is the query, but the else and the other should not be included. And let's finally create this search state. Oops. Search state, yes, that's the one. So I'm missing matches there. It's gonna be val matches. It's gonna be a data class, which would also derive from the search state. I'll move it close to the match. And yeah, that's my test. Now let's run it and watch it fail. Okay, now we have the problem with the looper. Let's add that extension here, which is the instant task executor extension. Now run and watch it fail. Yeah. Now we have that one failing for the reason we want it to fail. So it says we are expecting matches, it gives us the first one that it found. That's great. Now let's go ahead and make this work. So essentially I can go by checking if the available items, the available values has 1 or more than 1 matches, but maybe I can directly do something like skip a step, sort of. Filter contains the query. Now I'll assign this into variable, and I'm gonna call it matches. That should not change much. Okay, and I'll make it a bit smaller as well. Now here in the if, I can do well, no, let's first fake it till I make it. So if matches count is greater than 1, then do the new thing, which is return search state matches, and that should make the test pass. Great. Now let's check this in first, and then we can focus on refactoring. Can find multiple matches. Can multiple matching values, something like that. Cool. Now let's refactor a bit. So essentially here I can replace this check with matches count equal to 1. So if it's 1, yeah. And then instead of this, I want to replace this one with matches first. That should still work. And now I can inline this one. Good. And I can also go a bit step further. So let's maybe replace the return with if expression, which would remove the return and it would make it inside. And then this one will let me do, well, first let's run, make sure we are still green. And then I can do else if. That should work. And I can reformat a bit. So I'm making sort of the similar things look more similar. And then I think I can now lift the return. And now this, yeah, I don't want the when. I want this one is fine. Cool. So what I can say here is I can check this in first. And I can say simplified the search algorithm. And next, as a refactoring, what I'm having in mind is to, instead of having match and matches, wouldn't it be cool to have only matches and then no matter whether I have one or multiple, return that in a list? Because for the UI it wouldn't change much. And essentially I'm not gonna change much, but I'm gonna eliminate code, which is great. So let's do that first, maybe. So how do we do that is here, well, maybe this one we could cross it. Okay, yeah, here. So now the problem is in the one of the previous episodes we dealt with primitive obsession. I think we started with dealing with the primitive obsession, but we haven't completed that one. Essentially, we didn't predict that we could make this match. We can have matches, you know. Would have been nicer to do that because there is no automated refactoring that will help me do this. And I hate when I have to, I mean, this is small exercise, this is all good because I have only 2 tests, which is match found and another match found here, that are actually having this match, that are using the match. But if I had multiple places, it's really important to narrow down only to this replacement because it has to be done manually. There is no way I can do that automatically. And in that sense, it's really important to keep that change narrow because I have to do that, as I said, manually. So I won't, you know, lose focus and screw up things. Of course, I have micro commits, which is not going to be anyway a big deal. But again, I think I feel more comfortable when I do that way. It would have been great if I can, you know, do a refactoring that will put this into a list and then change the match, rename into matches, but I don't have that ability, at least not to my knowledge. And that's why here, as you have imagined, find one match, we procrastinated a lot to split, and this is good. I mean, turned out to be a good thing at this moment because I mean, okay, wouldn't change much, wouldn't have changed much because I have only these 2 tests in one test case. They would have been in one test case anyway, but yeah. Procrastination seems like it's the best, only good when doing TensorRT development. Only when writing the code, the tests, procrastination is good, like to split things, you know, early. Just wait until you get enough evidence and only then do the thing that you might think that you have to do. So yeah, enough talking. So I have to hard code, I mean, do the manual change here, matches, and then wrap this into a list of item 1. and do the same here. And if I run, 2 tests will fail. I also hate having 2 tests failing because of the single refactoring, but as I said, I have no other options at this moment for this one here. So yeah. And how do I make this pass is instead of if matches is not empty, and that should make all the tests pass, and it does. And what I could do is now I can eliminate the else if, and that's gonna work, and it does, which is great. And that means that I can also remove the unused data class in the search state, and that should also work. Cool. So now let's check this in. Now I would say well, removed duplication, I would say. Great. And now let's maybe, if we go back to this list, split the find one match test. So essentially what I was thinking of is like come up with another test case here and name it find no matches test. And then I'll make this smaller. I'll close this one. The tests from here that are not dealing with finding items, which are all of these, I want to move in the other test case. Now it is questionable whether I should mix the no match found with the empty query, with the query things, but the essence, I mean the behavior eventually is like finding no matches, no, regardless whether it is error of like having bad query or no match for a given query. So I think it's up to you. I mean, if you and I were pairing on this one, we would have decided together. This way I just think that I'm fine doing this one. So first let's import, and then I think, yeah, I won't need this here. I'll need to borrow the setup as well. And also the searcher. And I think finally I need this one as well. Oops. And that should work. Right, so now I have find one match, no matches, and multiple matches. That's great. Let's check this in. And then the commit message would be find, split tests to test cases that would better describe the behavior they check. Good. Now let's cross this one. And what we spoke about previously is this repository now. The thing that now we want to, now we have this repository, we are passing configuration inside here, which is the available values, and that's great. But the problem now is that we might have we want to deal with, let's say, we want to be able to load values from remote repository, from local repository, which is, let's say, database, and perhaps an in-memory one for the tests. But now the thing is that I'm thinking whether I should do that with the repository, so extract an interface and then handle the different situations based on like whether it is remote or whatever, or maybe offload that one into one level down, so into sort of another collaborator. So my reasoning at this moment is that if I, for example, have let's say I'm having database and remote, an API that I'm gonna be calling, and those two are having they are storing the models like differently. Let's say the data, the type of data that I'm getting, the models that I'm getting from remote and from database, they look, let's say, one way, but my domain model is looks differently, let's say. So I'll have to introduce some sort of mapping. Maybe that mapping is not going to be happening in the repository, but the repository will be responsible for, calling a collaborator, let's say, to do the mapping, but the mapping will be happening somewhere in this layer in the repository. So I'm thinking about offloading having another layer, another collaborator that will be doing the actual filter, which is going to be, let's say, in memory, remote, whatever, and then this repository will do also the translation. So for example, let's say I have result, I have exceptional situations, so I have to catch that too. And then I'm thinking about coming up with contract tests out of the this other collaborator that will be born. But yeah, let's see how that's gonna work. So first of all, I want to create so this repository shouldn't be taking available values as a list argument, but rather get an abstraction. Let's name it a service. So it's gonna talk to a service, and then the service will have different implementations: in memory one, remote, database, that kind of things. So let's see. So first, I'm gonna create a function here. Well, first, before everything, here, introduce additional service layer, and then handle exceptional situations, like real exceptions. And yeah, we'll see what comes next. So I'm not sure if I'll be touching the tests here. The tests should be green, as they are. So I just want to introduce this layer. Let's see. So first, I'll create a function, find matches, and then this one is the function that belongs somewhere else, or I believe that it belongs somewhere else. So let's first, can I do this? Yeah, I like this. I like it better. So as I said, we are gonna be introducing a collaborator here. And the easiest way to do that is, let's say I can create a class that's gonna be in memory search service. Alright, and then that's gonna have this function inside. And now, of course, it doesn't have access to the available values, so let's make this. Can I make it? No. Inner. And that should be of no consequence because it does not really touch any code. I just introduced the class here. So first thing is, let's make available values of the in-memory search service a constructor argument. So let's do that first. Oops, I should have named these available values. And let's do a bit of formatting for now. So it wants to make this one private. And now I think I can remove the internal. And that should be also of no consequence. And now here I can, instead of find matches, use the in-memory search service instance to do the lookup, and then I'll pass the available items that are coming in the repository. And that should still work. Everything should be still great. Yeah. And what I can do next is I can extract this one. I can extract it into a standalone class. And let's keep the name as in-memory search service. And let's look at that a bit later. But now this one should still work. And I can now introduce this one as a collaborator in the repository. And I'll make that search service, which is gonna be private, and that should still work. And it does. And now I can get rid of this function here, which should be still okay. And it means that I can also, now the available values are unused. So I can actually change the signature of the entire class and remove the available values. Do this refactoring. And that should be still green. So in essence, I've raised up the level of abstraction a bit here. So that's great. Let's check this in. So what I've done is pushed the search algorithm into a separate collaborator. And cool. So as I said, let's go back here. So this is the in-memory search service, but I think we are running a little bit over 25 minutes. So the idea is to, out of this in-memory search service, we are going to extract an interface, which is going to be the search service. Then we'll write contract tests for the actual in-memory search service that, using the in-memory search service, we are going to write contract tests that every new implementation will have to pass. For example, remote or database search service, they'll have to pass those contract tests. That's gonna be an interesting one, but I'm gonna leave that for the next episode. For this one, I think it's enough. Let's first write down maybe here, because yeah, we've done this one, but we wanted to do extract interface from the in-memory search service. Right. So we want to extract the interface and then depend on, let's maybe actually, it's kind of small refactoring to do. Oops. That's gonna be extract interface to separate file, name it search service, and take the function, which is great. So this one is no longer needed, and here, instead of in-memory search service, we are gonna be let's do it properly. So here I think we are gonna use search service, I think that one should still work. And it does, which is great. Now let's check this in, and that's it. Or the good. And yeah, that's I think that's gonna be enough for this episode. So I wrote here that we are gonna focus on contract tests and then handling exceptional situations, which is sort of part of the contract tests. And yeah, I think we can get rid of this one because we have the actual filter here, the contains thingy. So I think we are fine. Okay, thank you so much for the time watching this episode. I hope you like it. I hope you like this new format of the actual video, the audio. Hopefully it's better than the previously. The background music, I am using the no copyright sounds. You can find them on YouTube everywhere. They are no copyrighted. So yeah. And yeah, thank you so much for watching. Have a great time and see you for the next episode. Cheers.